So, hello everyone. In the series of revision classes, lastly, I have started the chapter Work, Energy, and Power. I have completed important questions and important topic of that chapter. Now, one or two more numericals of that chapter I am discussing. After that, I will discuss a new chapter that was your surface tension. Okay, so it's just a minute, 1 minute only. So the first question of the chapter is, if the linear momentum of a body, if the linear momentum of a body increases by 20%, increases by 20%, so what will be the percentage increase in the kinetic energy of the body? Kinetic energy of the body. So see the solution. Linear momentum of a body is increases by 20%. Let the initial momentum, let let the initial momentum be P and K. Okay. So what is the relation between momentum and kinetic energy? I have proved in previous video that Ke is equal to P square by 2m. So let the initial momentum be P and Ke be K. So we know that K is equal to P square by 2m. Now what is the condition given in the question? That the momentum of a body increased by 20%, means the new momentum will be increased. Increased means P plus 20%. Okay. So P plus 20% means 20 upon 100 of P. That means 1 upon 5 of P. So it is equal to, if you take LCM 5, so you will get 5P plus P. 6P by 5 as your new momentum. And the question is saying the momentum of body increased by 20%. Increased by 20% means, suppose we have 100 rupees. If we increased by 20%, what it means, that it is increased by 120. Okay, means initial plus 20% of initial. So that's why we I have write P dash is equal to P plus 20% of P. Means the momentum of a body increases by 20%. Okay. Now the final momentum will be 6P by 5. Now the new Ke will be K dash is equal to P dash whole square by 2m. So what is the value of P dash? P dash is equal to 6P by 5. So the value will be 6P upon 5 whole square, or 1 upon 2m. So 6P means 36P upon 25 into 2m, P square by 2m. And P square by 2m is K. Initial kinetic energy is P square by 2m. So in place of P square by 2m, I can write K only. So K dash will be 36 upon 25K. Now the change in kinetic energy of the body. Well, because the question is asking what will be the percentage increase in the Ke of the body. So how we will find the percentage increase? Percentage increase in Ke of the body. Percentage increase means change in Ke upon original Ke. change in Ke, or you can say the initial Ke, initial Ke upon 100, Ke into 100. Okay. So change in Ke is K dash minus K, and initial K is K into 100. So what is K dash here? 36 upon 25 K minus K upon K into 100. Now, if you take LCM, so you will get 36K minus 25K upon 25K into 36 upon 25K, okay, into 100, into 100. So 36 minus 25 is 9K upon 25K into 100. So you will get answer as 9 4 36%. So the percentage change in KE is 36%. Okay. We understand? This is a very important numerical for your exam point of view, the percentage change in P and the percentage change in K. Okay. So firstly, we have taken the initial momentum P and kinetic energy K. Now we know that the relation between kinetic energy and the momentum is K is equal to P square by 2m. The question is given that the linear momentum of a body is increased by 20%. So firstly, we have initial momentum as P. Now, if I increase the 20% of P, means 20 upon 100 of P. So our final momentum will be 6P by 5. Now, our new K dash will be final momentum square upon 2m. So 1 upon 2m of 6p upon 5. The value of p dash is 6p upon 5. So we get the k dash as 36 upon 25 of k. Now the percentage change in kinetic energy of the body can be calculated by the formula the change in Ke upon initial Ke into 100. So the change in Ke is k dash minus k, and initial Ke is k into 100. On solving, we will get an answer as 36%. Now, come to the next question. So the next question is saying that if the kinetic energy of a body increases 300%, by what percent will the linear momentum of a body increases? Will the linear momentum of a body increases? Now come to the solution part. Again, we can take initial momentum as P and kinetic energy Bk. Let the initial momentum Bp and kinetic energy Bk. So we know that K is equal to P square by 2m. Here the kinetic energy increases. So the factor which is changing here is kinetic energy. Okay. So P is equal to under root 2mk. That was the initial momentum. Now the new kinetic energy is increased by 300%. Means initially is K and then we have increased in it, means 300% of K. So K plus 300 upon 100 of K. So I will get K plus 3K as 4K as answer. So the K dash will be 4K. That means the new kinetic energy will be 4 times of old kinetic energy. Okay. Now the new momentum will be P dash. P dash is under root 2m of K dash. And what is the value of K dash here? 4K. So 2m of 4K. So if you take 4 and 2mk. So 2mk is, okay, wait, under root 4 is 2. So under root 2mk. What is 2mk? Here, initially it is P. So new P dash will be 2 times of P. Okay. The question is given the kinetic energy of the body is increased by 300%. So we have increased kinetic energy as K plus 300% of K. Increased by, na, by means that you have to add that percentage in initial value. Okay. So K plus 300% of K. So we will get K dash as 4K, and P dash, now new P dash will be 2m of 4K, and we will get P dash as 2P. Okay. So the percentage change in momentum, as question is asking to find the percentage change in momentum, no? So percentage change in momentum will be change in momentum upon initial momentum into 100. Initial momentum into 100. So the change in momentum is P dash minus P upon P into 100. So new P dash is 2P, as we have proved earlier, no? So P dash is equal to 2P. So 2P minus P upon P into 100. So 2P minus P is P upon P into 100. So the percentage change in momentum will be 100%. The next question is, the kinetic energy of a body, the kinetic energy of a body decreases by 19%, decreases by 19%. So what is the percentage decrease? What is the percentage decrease in its linear momentum? In its linear momentum. Okay. So the question is given that kinetic energy of a body is decreased by 19%. In that case, the kinetic energy is decreasing. So see the solution, how we can find. You can write same line as let the initial momentum will be P and kinetic energy will be K. Now the new K dash will be decreased by 19%. So K minus 19% of K. So K minus 19% means 19 upon 100 of K. So new K dash will be 100K minus 19K upon 100. So it will be 81K upon 100. So the new K dash will be 81K of 100. We know that K is equal to P square by 2M. So P is equal to under root 2 mk. Okay, that was your initial momentum. Now the final momentum percentage change in P 81 k upon 100. Okay, wait. Now that your new momentum will be under root 2m of k dash, and k dash is 81 k upon 100 under root 2m 81 upon 100 k. I can write it as 9 upon 10 of under root 2 mk. Under root 2 mk is initial momentum. So 9 upon 10 of p. So new p dash will be 9 upon 10 of p. Now the percentage change in momentum will be percentage change in momentum will be final momentum minus initial momentum upon initial momentum into 100. So the final momentum is 9p upon 10. 9p upon 10 minus p upon p into 100. Now if you take LCM, so you will get 9p minus 10p upon 10p into 100. So that 0 will be cancelled. So p upon p into 10. So you will get minus 10%. That means momentum will be decreases. Momentum will be decreases by 10%. Now the next question is, two bodies of masses, two bodies of masses 1 gram and 16 gram are moving with equal kinetic energy, are moving with equal kinetic energy. Find the ratio of, find the ratio of the magnitude of linear momenta. The magnitude of linear momenta. Momentum is a plural of momentum. Linear momenta. Now see the solution. The two bodies have equal kinetic energy. That means Ke of 1 is equal to Ke of 2. And the mass 1 is given as 1 gram and mass 2 is given as 16 gram. Find the ratio of the magnitude of linear momentum. Let the body first have momentum P1 and the body second have momentum P2. Okay. So P is known as K is known as Ke is known as P square by 2m. So P1 square is equal to 2m of Ke. So P1 is equal to under root 2m of Ke. Now P1 ratio P2 means P1 upon P2 is equal to under root 2m1 Ke1 upon under root 2m2 Ke2. As we can write it as under root 2m1 Ke1 upon 2m2 Ke2. As Ke1 and Ke2 are equal, so 2 and 2 is cancelled, Ke1 and Ke2 is cancelled. So P1 upon P2 is equal to under root M1 upon M2. M1 is 1 gram and M2 is 16 gram. So the ratio will be 1 upon 4. So P1 ratio P2 is 1 ratio 4. P1 ratio P2 is 1 ratio 4. Okay. Now come to the next chapter, that was your surface tension. Okay. So firstly I will discuss about the what is surface tension, what are its properties, the surface energy. After that I will solve some previous year questions of this chapter. Okay. Now today our chapter is surface tension. First is surface tension. So before surface tension, you have to know about the two forces. First is cohesive force and second is adhesive force. Okay. So first is cohesive force. Cohesive force means it is the force of attraction. It is the force of attraction between the molecules of the same substance. Between the molecules of the same substances. It is a force of attraction between the molecules of the same substances. Means water is added with water, juice is added with water. So all are the example of cohesive forces. Okay. We have take the example of many juices. Maybe I know that you will know or not that rasna will be there. You can say that when we mix one quantity of juice with water, any juice will be there. Huh? So the molecule will be mixed. Okay. So the force between two different molecules of juices, both because both are liquid now. So that is known as the cohesive force. Okay. It can be in air. It can be also in liquid also. Okay. So next is your adhesive force. Adhesive force means it is the force of attraction, force of attraction between the molecules of different substances of different substances. Now you have seen in the many cases then when you drink water, so the water droplets remain at the wall of a glass. Okay, that was known as your adhesive force. Now come to the next one, that was molecular range. Next topic is your molecular range. So what is molecular range? It is the maximum distance. It is the maximum distance up to which a molecule can exert some appreciable force of attraction on another molecule. Force of attraction on other molecule. Okay, that was not so much important. And surface film. One more small topic is there. Surface film. Surface film means the thin film of a liquid near its surface. Okay, so that was if you see that this is a container full of water. So this film is known as surface film. Okay, the thin film of water near the wall of a liquid is known as the surface film. Okay, that was the surface film. Now come to the main part, which was your surface tension. Surface tension. So surface tension in many books is denoted by T is denoted by S or is denoted by sigma. So you can denote surface tension by any of the symbols. So the surface tension is the property of a liquid surface to remain in its minimum surface area. Okay. So the property of a fluid, the property of a fluid or liquid surface to remain in minimum surface area, to remain in minimum surface area, in minimum surface area is known as surface tension. Okay, is known as surface tension, is known as surface tension. Or you can say that it is the property, it is the property by virtue of which, by virtue of which the free surface of a liquid at rest behaves like an stressed membrane, behaves like an stressed membrane tending to contract so as to occupy minimum surface area, minimum surface area. Okay, so that was the definition of surface tension. Surface tension is mainly denoted by T, sigma or S. So sigma is equal to force per unit length. That was the formula of surface tension, the force per unit length, force upon length. Its SI unit will be the SI unit of force is Newton and length is meter. So Newton per meter will be its SI unit. Its CGS unit is dyne per centimeter. Dyne per centimeter. Now come to its dimension. Its dimension are force as dimension MLT minus 2 and length as dimension L. So MLT minus 2 upon L. So you will get MT minus 2 as its dimension. Its dimension is very important. Viscosity dimension is very important and gravitational dimension is very important for your exam point of view. So that was your surface tension. Now come to the molecular theory of the surface tension. That was not so important as your exam point of view. Molecular theory of surface tension. Theory of surface tension. But you can see that theory here. Okay, suppose that was the container filled with a liquid. That was a thin liquid film. So if a molecule is in the bulk of a liquid, so the force act on a body from all direction. So net force on that body will be zero. But if a body is in surface, so it will experience net downward force, due to which the upper membrane of a liquid behave like a stressed membrane. That means like that. Okay. So that was the molecular theory of surface tension. That's why the liquid surface have the surface film like that. Means not so much curve, but small curve in the surface, because the molecules in the surface experience only net downward force, not upward force. But in the the molecule in the bulk experienced from all direction. So the net force on the molecule in the bulk is zero. Okay. So the phenomenon based on the based on surface tension. So some phenomenon based on surface tension, based on surface tension. First is needle supported on a water surface that was due to surface tension. Raindrop are spherical due to surface tension. Raindrop are spherical due to surface tension. Third one, small mercury drop are small mercury droplets are spherical, and large one tends to flatten. Tends to flatten. Fourth point, hair of painting brush, hair of painting brush clings together when taken out of water. When taken out of water. And the last one, oil spread on cold water but remain as a drop on a hot water. As a drop of, on a hot water. So that are some example of the surface tension. Now one more example is that the if we add water to the clothes, suppose that was a cloth, that was a shirt. So if we, that the dirt is there, okay. So if we dip this shirt in a in normal water, so that dirt will not remove. And if we put this shirt in a soap solution, so that dirt will be removed. Okay, how this can be possible? That the sigma means the surface tension of water is 0.075 Newton per meter, and the soap solution has surface tension 0.03 Newton per meter. So the soap solution has very less surface tension. That's why it is easy to remove the dirt from the pores. Okay. And generally, hot water is also required to remove the dirt from the particle. So what do we get from hot water? So from hot water, the surface tension is decreases. Okay. So if the surface tension decreases, so it can go in the pores and remove the dirt. Okay. So what we conclude from here, we conclude one more term from here, that by hot water means we increase the temperature. So by increasing the temperature, surface tension of the bodies decreases. Okay. So surface tension depends on the temperature. So if we increase the temperature, so surface tension of the body is decreases. Now, suppose this is a body. Okay. That was a movable piston here. If we dip it in a soap solution, so what will happen? It will tends to minimize its surface area. Why it's minimize its surface area? Because the soap solution has less surface tension. So that's why it is surface tension is the property to remain in minimum surface area. So it will goes toward inside. Okay. So when we dip a movable piston, means a body like that in soap solution, so it will tends to move toward inside because uh, it wants to remain in minimum surface area. So okay, and on the basis of that I am giving you one question. Suppose that was a body having a movable piston that were as AB. Now if a mass M is hang to this part AB, so what will happen? So this will dip in the soap solution. Okay, so we have given the surface tension of the soap solution as 0.03 Newton per meter. So find the value of M, find the value of M such that the sliding R remains in equilibrium. Sliding remain in equilibrium. Now, if it is dip in the soap solution, so it will move toward upward, but it will make its downward. So the weight of the body is acting downward, and the surface tension, due to surface tension, it was moving upward. So if it is in equilibrium, for equilibrium, the value of both the forces will be equal. So F is equal to F. The net downward force is equal to the weight of the body mg. And the value of F is surface tension into length. We know that surface tension is equal to force per unit length. So F is equal to sigma into L. But here it is given that it is a soap solution. It is a soap solution. So we considered in physics that soap solution has two surfaces, two thin surfaces. So that's why we will take it as 2 sigma. Okay. So the value will be 2 sigma into L. Wait, you can write here, since soap solution, since soap solution have two surfaces, so it have two surfaces, so both surfaces will apply the force. Okay, so that is equal to 2f. 2f means 2 sigma into L. So 2 sigma into L is equal to m into g. We have to find the value of m. So the length of this was given as 10 centimeter. So take the G as 10. So M into 10 into 10 centimeter into sigma is 0.03 into 2. Okay, that was centimeter change in meter. So 10 upon 100 meter. So 10 upon 100 meter will be there. On solving, you will get M as 2 into 0.3 into 10 upon 1000. So on solving, you will get answer as 6 into 10 to the power minus 4 kg. Okay, that was the value of mass. So if the value of mass is 6 into 10 to the power minus 4 kg, so that's in that case the piston AB remain in equilibrium. Now come to the next topic, that was your surface energy. Surface energy. So what is the surface energy? The energy possessed by the molecules, the energy possessed by the molecules of surface film of unit area compared to the molecules compared to the molecules in the interior is called surface energy. Is called surface energy. Or it is equal to the work done. It is equal to the work done in increasing area of surface film by unit amount. So the surface energy is equal to surface energy is equal to work done per unit increase in surface area. Work done per unit increase in surface area. Okay, so work done is joule and increase in surface area is meter square. So SI unit is joule per meter square. Okay. So the relation between surface energy and surface tension, that was the main important topic of due to your examination point of view. So relation between surface energy and surface tension. Surface energy and surface tension. So consider a rectangular frame ABCD in which wire AB is movable. In which wire AB is movable. Dip the frame. Dip the frame in soap solution. A film is formed which pulls the wire AB inward to surface tension with a force F. The force F. So F is equal to 2 sigma into L because it is a surface film. So now I am drawing its diagram. Okay. Suppose that was a rectangular film A, B, C, D. AB of length L, sorry, AB and CD both of length L and CB of breadth X. Okay, so this is the soap solution. So soap solution has two surfaces. That's why I have taken force as 2 sigma into L. So that was moved inside. Okay, if I move it by at distance A dash B dash, which is delta X from B, so it will come at the position A dash B dash. If I stretch it with force F. Now work done by external agent, work done by external agent is force into change in distance. So what is force? 2 sigma L into delta X. Now change in surface area. Change in surface area. So change in surface area is 2L. Initial surface area is surface area both are multiple of 2 because it has two surface. So what is the change in final surface area minus initial surface area? So final surface area is A dash B dash C into D. So what is it? Length into change, the breadth will be x plus del x. So L into x plus del x will be the value minus the initial surface area. Initial means A, B, C, D means minus 2L into x. Take 2L common. So you will get x plus delta x minus x. So the change in surface area is 2Lx. So surface energy is so surface energy is equal to work done upon increased in surface area. So work done is 2 sigma L del x, 2 sigma L delta x upon increasing surface area is 2L x. Wait, that was x plus that is 2L delta x. So increase in surface area is 2L delta x. 2L delta x, 2L delta x will be cancelled. So equal to sigma. And what is sigma? Surface tension. So surface energy is numerically equal to the surface tension. Okay. So the SI unit of surface energy is SI unit of surface energy. So surface energy has two SI unit. First is by work done per unit surface area, that was joule per meter square, and second by surface tension, that means force per unit let, that means Newton per meter. Both are the SI unit of surface energy, and the dimensions of surface energy are same as the work done. Dimension of surface energy are same, mt minus 2. Okay, so that was your very important topic, and it have repeated in your exam 2 or 3 times. Okay, I go through that. No, 2 or 3 times not. It was come at means 4 times. I think 4 times. I will say in 4 paper. Okay, the relation between surface energy and surface tension. So we have dip in the soap solution, and soap solution has two surface area. That's why I have taken force as 2 sigma into L. Okay, so the work done by external agent to increase it, work done is force into displacement. So if we apply the force and the displacement is delta x, so we will get work done as 2 sigma L into delta x. And the change in surface area is initial surface area minus final surface area. Initial surface area is ABCD. Sorry, final surface area is A dash B dash A dash B dash C D, and the initial surface area is A B C D. So the change in surface area is 2L into x plus del x minus 2LX. So on solving, we have get 2L delta x as value. So on putting those value in the formula of surface energy, we will get surface energy is equal to surface tension. Okay, so that was main part. The surface energy is equal to the surface tension, and the SI unit and the dimension of surface energies are there. Okay, so that's all for today. In the next class, we will discuss about the pressure inside a soap bubble, pressure inside a water molecule means liquid drop. The difference in the pressure means na, and the height of meniscus. Okay, so that's all for today. If you have doubt in any topic, so you will send that doubt or question to Sarah ma'am. They will